One of the most eagerly anticipated astronomical events is the supernova of Betelgeuse. In the well-known shoulder of Orion, Betelgeuse is a red supergiant star that is nearing the end of its life. Betelgeuse is one of the night sky's brightest stars, but it mysteriously began to wane in the latter part of 2019. One might even see the dimming with unaided eyes because it was so obvious. For several months, the star's brightness diminished and observers questioned whether Betelgeuse had reached the end of its life. After a few months, though, the red giant star's brilliance returned to normal. Astronomers were astounded to discover the cause of the great dimming when they focused some of the most potent telescopes on it. This star is on the verge of exploding as it approaches the conclusion of its existence. When and why is a supernova predicted to occur? And will this situation be disastrous for Earth? Let's find out. The brilliant ruby-red glittering star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. It is also known as Alpha Orionis, the second brightest star in the constellation after the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations due to its variable nature, as well as its odd name. Frequently, stars with the name Alpha are the brightest in their constellations, even though Rigel, Orion's other bright star, is brighter. Betelgeuse is Alpha Orionis. Due to its name, brightness, size, and reddish hue, it is also one of the most well-known stars. Betelgeuse is the seventh brightest star that can be seen from most of North America, Europe, and Canada, and it is the 10th brightest star overall in the sky. The armpit of the giant is a common translation for the Arabic phrase that served as the basis for the name Betelgeuse. Naturally, the giant refers to Orion, although other scholars think that Betelgeuse, rather than an armpit, depicts a hand or maybe a shoulder. Although Betelgeuse is depicted as Orion's right shoulder on many old star charts, its precise significance is unknown. Given that Orion is most usually connected with a giant, a warrior, a hunter, a god, or some other anthropomorphic or animal figure in ancient mythology, it is scarcely surprising that most portrayals of Betelgeuse have an anatomical association. Surprisingly, astronomers are unable to pinpoint Betelgeuse's exact distance from Earth, although they believe it to be between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star and is closest to Earth. In our galaxy, just 200 red supergiant stars have been identified. Betelgeuse is 16.5 times as massive as the Sun. The supergiant has 126,000 solar luminosities and is visible from 548 light-years away. This star has a surface temperature of 3,600 Kelvin, making it cooler than the Sun. Only about 13% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would overtake Sirius as the brightest star in our night sky. The Sun has a radius that is around 764 times larger than Betelgeuse. If this star replaced our Sun in the solar system, it would reach past the asteroid belt and even beyond Jupiter. This implies that Earth, Mars, Venus, Mercury, and Venus would all be completely absorbed. Betelgeuse loses about 1 solar mass every 10,000 years. A nebula surrounds the red star because this material is being ejected unevenly from the star in all directions. A cloud of material 250 times larger than this star surrounds Betelgeuse, and the size of this nebula is also thought to be 30 astronomical units, AU, or 30 times the Sun-Earth distance. The Sun and Neptune, the furthest planet in the solar system, are separated by this distance. Red supergiant Betelgeuse is estimated to be between 9 and 10 million years old, which is a relatively young age. It is believed that supergiant or red giant stars are nearing the end of their existence. When a star is born, it is made of hydrogen, which fuses together in the star's core under the force of gravity to create helium in a nuclear explosion. A lot of heat and light energy is typically released during the fusion process. This energy travels to the star's surface and is released as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium starts to combine with carbon to form carbon. After the helium is used up, neon will eventually combine with carbon to form iron. When this happens, the fusion of neon with iron absorbs energy instead of releasing it. Because there is nothing to oppose the star's very powerful gravity, when iron begins to fuse, the star collapses in on itself, giving rise to a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change hue during the course of their existence, from the youngest, hottest blue forms to the older, cooler red varieties, depending on what stage of their stellar evolution they have reached. The Greek scientist Ptolemy, 90 to 168 AD, strangely referred to Betelgeuse's color as having a ruddiness. Yet 3 centuries earlier, Chinese astronomers had characterized the star as having a yellow appearance, possibly implying that Betelgeuse was formerly a yellow supergiant. Larger stars frequently burn through their hydrogen faster and die off sooner. Despite being only roughly 10 million years old, Betelgeuse is certainly nearing the end of its lifespan. Our Sun, on the other hand, is still in its prime at approximately 5 billion years old. Furthermore, because Betelgeuse is nearing the end of its life, a supernova may occur soon. However, it's hotly contested when Betelgeuse's supernova occurred. Betelgeuse undergoes 2 dimming and brightening cycles, the second of which occurs approximately every 5 years and lasts approximately 100 days. The star's outer shell is thought to expand and contract during this cycle, changing the star's circumference and the average temperature in accordance with each step of the cycle. The inconsistent dimming of Betelgeuse in 2019 and 2020, followed by a brief restoration to its usual brightness, drew a lot of attention. According to astronomers, it might indicate that the star is about to die. Betelgeuse has been the focus of intense study since the 1st century BCE. But why did it wane suddenly and against its usual cycle? Betelgeuse was evicted from its home in the Orion OB1 Association, which comprises the stars in Orion's belt, and has been seen moving through the interstellar medium at a speed of 30 kilometers per second. More than 4 light-years wide bow shock is being produced by this speeding star. It is difficult to estimate the distances to red supergiant stars like Betelgeuse in astronomy. It has proven challenging to pinpoint Betelgeuse's exact diameter for a variety of reasons. Betelgeuse is a pulsating star, therefore its diameter changes over time. The optical emissions shift in color and weaken with distance from the center due to limb darkening. Therefore, there is no distinct edge to the star. The circumstellar envelope, which is made of material ejected from the star and emits and absorbs light, makes it difficult to define Betelgeuse's photosphere. The star's apparent size varies depending on the wavelength utilized, making it difficult to compare one observation to another. Within the electromagnetic spectrum, measurements can be done at various wavelengths, and the reported diameters can vary by up to 30 to 35%. Photos taken by the ground-based Very Large Telescope Interferometer (VLTI) in July 2009 and released by the European Southern Observatory showed a gigantic gas plume that reached 30 AU from the star into the surrounding atmosphere. The scale of this mass ejection, which was one of many occurring in the atmosphere of Betelgeuse, equated to the distance between the Sun and Neptune. Astronomers have discovered at least 6 shells surrounding Betelgeuse. By solving the mystery of mass loss during the last stages of a star's life, it would be feasible to determine the reason for these stellar giants' terrible demise. Along with the star's diameter, issues have been raised regarding the complex dynamics of Betelgeuse's extended atmosphere. Red supergiants play a significant role in the recycling of matter that makes up galaxies, although it is yet unclear how mass is lost. Thanks to advancements in interferometric techniques, astronomers may be close to solving this problem. Astronomers utilized Hubble and other observatories to discover that the star ejected a considerable amount of its visible surface in 2019 and produced a huge surface mass ejection, SME. This has never before been seen in a star's behavior. Our Sun regularly ejects pieces of its thin outer atmosphere, the corona, in a phenomenon known as coronal mass ejection, CME. Those events are orders of magnitude weaker than what was observed on Betelgeuse. The Betelgeuse surface mass ejection, or SME, ejected 400 billion times more mass than a typical coronal mass ejection, a CME, which explains why. By mid-February 2020, Betelgeuse had lost around 3 times as much brightness from magnitude 0.5 to magnitude 1.7, after beginning to decline sharply in October 2019. By February 17th of 2020, Betelgeuse's brightness had been stable for almost 10 days, and the star had started to brighten once more. However, Betelgeuse appeared to have stopped dimming completely 5 days later, effectively ending the dimming episode. Given that there were no significant changes in the infrared on February the 24th, 2020, it appeared that the recent visual fading was unrelated to the anticipated core collapse. Another study that day concluded that the star's dimming was most likely caused by occluding large-grain circumstellar dust. Dust absorption is ruled out from having a significant effect in the study that uses measurements at sub-millimeter wavelengths. But the fading appears to be caused by large star spots. Further analysis showed a dramatic rise in Betelgeuse's brightness. The finding of a second dust cloud coming from Betelgeuse, which was linked to a recent considerable dimming of the star's light, was revealed by astronomers on August 30th, 2020. In June of last year, it was suggested that a cool patch on its photosphere might be the cause of the dust, and in August, a second independent investigation confirmed the initial hypotheses. The dust is thought to have been created by the gas that the star expelled by cooling. According to studies done in 2022, using the Hubble Space Telescope, occluding dust may have been created by a surface mass ejection. The material was ejected from this star's surface millions of kilometers away, where it cooled, compacted, and formed the star's fading dust. A dust cloud that covered the star from Earth-based observers was created when the photosphere, which was roughly several times as heavy as our Moon, broke apart and drifted off into space. The fading, which began in late 2019 and continued for a few months, was plainly discernible even by backyard observers who observed the star's brightness change. Even more remarkable, the 400-day pulsation rate of the supergiant has vanished. Since around 200 years ago, astronomers have been tracking this cycle by analyzing changes in Betelgeuse's surface motions and brightness variations. Its disturbance reveals the extent of the blast. Astronomers have now developed a potential theory to account for the disruption. The photosphere is also renewing, and the star is slowly regaining strength. The star's normal cycle is being thrown off, and the interior is vibrating like a bell that has been slammed. These findings shed light on how red stars lose mass as they age and eventually explode as supernovae when their nuclear fusion furnaces run out of fuel. The amount of mass loss has a significant influence on their fate. Betelgeuse's exceptionally rude behavior is also not a hint that the star is about to become popular overnight. Consequently, a significant loss event is not always a sign of a coming explosion. Betelgeuse is now having trouble recovering from this wound. Convection cells within the star, which produce the regular pulsing, are thought to be swirling around like an imbalanced washing machine tub. According to TRES and Hubble spectra, the surface is bouncing like a dish of gelatin dessert as the photosphere reconstructs itself. However, the outer layers appear to be returning to normal. Even while our Sun regularly encounters coronal mass ejections that blast off small fragments of its outer atmosphere, astronomers have never witnessed such a large percentage of a star's visible surface get thrown into space. As a result, surface mass ejections and coronal mass ejections can happen independently of one another. Scientists said that a massive star surface mass ejection has never been observed before. There is still something going on that we don't fully comprehend. We may observe this brand new phenomenon directly and use Hubble to discern surface features. Real-time observation of the development of stars. As the ejected material continues to move away from the star in infrared light, NASA's Webb Space Telescope may be able to see it. The fading of Betelgeuse has finally stopped, and could reclaim its ranking as the 10th brightest star in the sky. Betelgeuse is around 100,000 times brighter than the Sun, making it one of the brightest stars in the sky despite being far away. Such brilliance comes at a price. Fuel must be consumed quickly to keep up with Betelgeuse's enormous energy, hastening its destruction. When the star eventually runs out of fuel, it will fall under its own weight and then erupt into a dazzling supernova. Then, for a few weeks or months, Betelgeuse will grow extraordinarily bright, possibly equaling the brightness of the full moon. It will become visible throughout the day. What time will it occur? Probably not in our lifetimes. However, nobody actually knows exactly when it will happen. It might happen tomorrow, or in a million years. Will the Betelgeuse supernova destroy Earth? No. The explosion of Betelgeuse won't affect or even partially end life on Earth because it will occur too distant from the planet. Astronomers estimate that for a supernova to be dangerous to humans, we would need to be 50 light-years distant from it, and Betelgeuse is over 10 times farther away, as well we know. Instead, everybody on Earth at the time will be treated to an extraordinarily breathtaking view of a very, very bright star in the night sky. Finally, because of Betelgeuse's proximity, astronomers will be able to study the star when it undergoes a supernova. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.